Good evening and welcome. My name is Kevin. I'm the president of the North Jersey Astronomical Group. And with us tonight, we have Mark Zdarsky, who is our observatory chairman. He's got his telescope set up at his house in Apacon in Morris County, or sorry, Sussex, lower Sussex County. Right?
Just on the border, yeah, almost, kind of right there.
Yeah. And we also have Dr. Mary Lou West, who is a professor emeritus at Montclair State University. So she'll be, you'll hear her chime in on various objects as we're looking at them. And so let's get started. We've got a beautiful night. And Mark has his telescope set up there. He's got that's an 8-inch telescope, right, Mark?
This one tonight is an 8-inch, yes.
Yeah,
an 8-inch.
Yeah. So he's got an 8-inch telescope set up there. And right now he's pointed at the moon. And so let's start out with that. We're going to have Mark share his screen with us. And we're going to take a quick look at the moon. And then as it gets darker, we'll be able to see other stars and take a look at a few other things in the sky.
Back in the screen here.
Right.
Unfortunately, I can't fit the entire moon into the whole frame, but if we need to move it, get it to do that, let me know, and I can do that for us.
So here we have a beautiful crescent moon. We're one day away from first quarter. First quarter moon is tomorrow night. So we've got a nice crescent to look at tonight. And you know, a lot of people talk about the full moon. I think the last time we did a stargazing session for Buzz Aldrin Middle School, I think we mentioned this, that a lot of people talk about the full moon, and often people want to go out and look at the full moon, and that's great. It's, you know, big and bright at that point, but I think the best time to look at the moon is right now, before you get the full moon, because look at all the beautiful craters that are visible here. You've got the surface of the moon covered with all these craters, and I don't know if we asked this question last time, but maybe we could ask the students who have joined us. Does anyone know what creates those craters on the moon? If anyone knows, you can feel free to unmute yourself, or you can use the chat box if you want to use that. What causes these craters on the moon? How did the moon get all of these craters? Anybody know? Okay. Samantha mentions asteroids. Sure, yeah, sure. You can have asteroids can fall down onto the moon, and so how did the moon get these craters? How did those asteroids cause those craters? Or can you think of something else that might cause craters besides just asteroids? Anybody want to take a guess? No? No guesses? How about, think about what might fall from space or something that you'd see up in the sky. You know, sometimes people refer to them as shooting stars. Mice. Someone suggested mice. Well, if the moon was made of cheese, sure, yeah, you might guess that mice chewed holes in the moon. That's of course something that people used to talk about, or used to say that the moon was made of cheese. It looked like it was made of cheese, but obviously it's not. It's made of rock. And Mark, you could maybe tell them a little bit about the geology of the moon. What is the moon made of?
Right. So from what we believe and what we understand of the chemistry of the moon and the history of the moon, that it was created from an impact of another body, a Mars-sized body that hit the Earth early in its history. And so when it hit the Earth, and the debris, some of it got absorbed into the Earth, but the rest of it got spewed out around the planet, recaptured, coalesced, and became the moon. And slowly, this it was molten rock to begin with, and slowly it began to cool. So a lot of these brighter patches you see in the moon here, and the far side, incidentally, has a lot more of these higher, these brighter patches. These are the lunar highlands. And if you look at some of these darker patches here, they occurred later. These are volcanic eruptions that filled some of these craters later on. But about, the early history of the solar system was kind of chaotic and some would say violent. You'd have a lot of these small planets and asteroids colliding with the Earth and the moon. But the Earth is geologically active and we have weather, and it kind of erases these processes. What you see on the moon here is basically a pristine record of all the impacts, because there's no weathering, there's no weather on the moon, there's no geology. Well, there's geology, but there's no active geology at the moment. So basically, you're seeing it frozen in time, the compilation of all these impacts between different asteroids, comets, and other heavenly bodies that have come across the moon's path during this time period. So these brighter areas are called a rock called anorthosite. If you go to the Adirondacks, you can actually find something similar on the Earth. But it's basically an aluminum-rich metal, calcium aluminum-rich metal. And that's, captured within the rock, formed within the rock. That gives the moon this lighter color. The darker color is a basaltic lava. And the example I would give for that is right in Buzz Aldrin Middle School's backyard, the Watchung Mountains. So right, that hill just to the west of Buzz Aldrin Middle School is made of the same type of rock that these dark patches of the moon are made of. And it's a iron-rich rock, and that's why it's got a darker color to it. So iron and magnesium rich.
Yeah, so we've got all this stuff raining down on the moon and creating these craters. And so you have asteroids. I think Mark and also someone in the chat mentioned meteorites. You have these little chunks falling down on the moon. Another thing that can cause craters is comets, right? You get these big icy objects that are floating out there in the solar system, and they can cause craters as well. I don't think we know for sure of any craters caused by comets on the moon, as far as we know, but certainly we know that comets can hit planets, and we've actually seen it. I forget what year it was. It was late 1990s. It was 97 that the bits of a comet hit Jupiter.
Oh, 94, the Shoemaker.
94. I'm sorry. Yes, 94. Right. Yeah. So we've actually seen comets hit other planets. So yeah, there's stuff out there, and it's all, basically some of those collisions are caused by gravity. The gravitational pull of these bodies will pull in some of these objects floating right out there in space, and end up with a collision. You end up with this crater, and as I mentioned, this is a really good time to look for those craters before you reach full moon. You can see that the sun is kind of rising across the surface of the moon, and you get these nice shadows. It almost looks three-dimensional when you zoom in. So here's Mark's zooming in a little bit there, and you see these beautiful craters, and they're lit up by the sun as the sun gets higher in these areas. That's where the sun is rising on the moon, and so you get a beautiful view of these craters here. And remember, this is a live image. It's not a still image. This is an image that Mark is capturing there live with his telescope. Okay. And so there are some interesting things to look at here on the moon as you scan around. Mary Lou, you want to talk about some of the interesting areas that we can look at here on the moon?
Sure. So in the upper right there, you have several dark circular areas. So the one that's right where Mark's pointer was, so the one that's freestanding there is called Mare Crisium. the Sea of Crises. So that's kind of worrisome, I guess, in that idea. So anyway, Mare Crisium is about 570 kilometers across. So that's a big piece of land there. It was a very deep crater early on, and then the lava came up from below. And as Mark said, the lava is basaltic and darker in color than the rock that was on the top. So that's hardened lava there. You can walk around on it just fine. So if we look just to the left of it, there's a little bright crater there that's called Proclus, named after some ancient mathematician. At any rate, Proclus is an interesting place to look at with a telescope, because when the rock came in, the asteroid or the meteor, and hit it, blasted up the topsoil, and all sorts of white topsoil, lighter colored topsoil went flying around, but it never flew off to the left. So there must be a big rock or something just to the left of where that crater is that blocked the ejecta from going to the left. So we don't know quite why, but can you see that sort of shaded region there? Yeah, it didn't get there. So if we back out a little bit, we could see some of the other big mare regions. So the one at the top there, which is quite round, is called Serenity. So that should make you feel serene and nice to look at that one. And then below that is Tranquility. And something interesting happened in Tranquility many years ago. Anybody know what happened in the Sea of Tranquility on the moon? About 1959?
59.
Yeah, 1969.
1969, yeah.
July 20th, 1969. Ring a bell. It has a very local connection to where you guys live. Someone put it in the chat and it's mentioned Buzz.
Yay, Buzz!
Buzz Aldrin, right? And so Buzz Aldrin and Neil Armstrong were the first people to set foot on the moon, and so that's where they landed. Was right there in the Sea of Tranquility.
It's in the Sea of Tranquility, which is that second big dark area down from the top, sort of at the same level as Crisium, and they landed sort of toward the bottom left of it. So when I look at the moon without a telescope, just with my eyes, I like to figure out where that is. So if we could back out and see the whole crescent moon again. So it's almost halfway from top to bottom. You go top to bottom, pick the middle there, yeah. And then you go from the center of the moon off to the right, and you pick halfway, and it's right in there. So there's where they landed. Of course, we can't see it, not with this telescope. But they left some equipment there and some litter and lots of footprints. That would be cool to go there and look at their footprints, I think.
Yeah, a lot of people will ask us when we have our telescopes pointed at the moon. They'll ask us if we can see the footprints or can we see the flag on the moon. And no, we can't. Not even the best telescopes in the world are able to resolve that sort of thing. But we have seen quite a bit of detail with spacecraft orbiting around the moon. If I remember correctly, it was the Lunar Reconnaissance Orbiter is still in orbit around the moon, taking high resolution images of the surface. And they've actually seen the footprints and the tracks left behind by the lunar buggies that they drove across the surface. And so, and they also can see the landing stages as well are visible there on the surface. And you can go onto the LRO, Lunar Reconnaissance Orbiter website, and take a look at some of those pictures that were taken of those landing sites.
Another thing, if you did come across the flag today, it would be bleached white from being exposed to violet light for so long.
Yeah, yeah.
Yeah, we should be happy that the Earth has an atmosphere that protects us from the ultraviolet light from the sun. We don't get all bleached or get skin cancer. So poor flag on the moon has got all got itself all bleached off. Mark, can we go to Clavius at the bottom of the moon?
Mm.
Yeah, let me see if I can just nudge the moon up a little bit. Oh, wrong way. Okay, let's see here. We can find Clavius.
I think it's too early.
Yeah, it's probably over here just
Yeah.
before.
Yeah.
But
One
but
of the
there are,
interesting things you can see right at the edge of the shadow there, the terminator, is that some craters have little mountains right in their middle and others don't. So, like that one right there has a little crater in the middle. That's backsplash. So when the rock hit, the dirt was splashed up and it made the rim of the crater, and then some of it whizzled back to the middle and made a little peak in the middle. Some of them have that and some of them don't.
Kind of like when water drops into
Yeah.
you know, a pool or a pond or your glass. There's always that part that kind of bloop, shoots up in the middle at the end if you look closely.
Yeah, that's right. Exactly right.
exactly
This
it.
one, can we trundle along up northward along the terminator, see if we see any others?
I think I see the lunar X. And the lunar X there on the left.
Oh, yeah.
Yeah.
Boy, you
Yeah.
don't see that very often.
That's a nice
Got
view.
lucky at that one. Yeah.
Yeah. Yeah, that's just a feature that you can often see at this phase of the moon. It's just you know, a bunch of craters are so close together there. You got these little ridges that are all merging, and you can kind of see a little X pattern there, can't you? And so that's the kind of lunar X. And
The high peak part of it. Yeah.
Cool.
Just catching the sunrise over the.
yeah, just touching the come to sunrise. So if you were standing there in that little spot there on top of one of those ridges, you would see the sun just rising up over the horizon there, sunrise on that part of the moon. And the valleys down below, the craters down below are all still in darkness.
Right. You know, almost as if you're in a valley.
Yeah, and there's a nice peak in that crater there where your mouse is.
All
Nice
right.
little peak up in the center
Quick
there.
question about sunrise that you guys were talking about.
Mhm.
Obviously, you know, the Earth is moving through space. You know, it's orbiting the sun. The moon is orbiting around the Earth, and it's also revolving on its axis. So, if we sat here and looked at the moon, how quickly is the sun moving like across the surface here? Like, how much will become illuminated in the next half hour or an hour if we were to sit here and watch the moon? Would it be something that we could significantly see? Or
Well,
is
you could a little bit, but it's pretty slow.
it,
I've
A
noticed
day
it.
on the Earth takes 24 hours to go around.
right?
A day on the moon takes a month to go around. So it's really pretty slow. And if you went to the moon and had on an outfit, you could go outside and you had boots on, you could run around. You could almost keep up with the shadow or the sunrise if you
Right.
ran
That
along
would be awesome.
pretty quickly. Can't do
Yes.
that on Earth. It goes hundreds of miles an hour here.
Yeah. So thinking about it that way, as Mary Lou mentioned, a full day is almost a month long, and so that means daytime. You've got day and night in that cycle. Daytime, if you stand in one place, daytime is going to last about 14 days, about
Right.
2 weeks, right? So about 2 weeks, 2 week long day, you know, before you see the sunset.
So it gets pretty hot during the middle of the afternoon of the moon.
Sure
Yeah.
does. Yeah.
Been sunshiny for a long time.
Yeah.
And then in the middle of the night, it gets really, really cold on the moon because it's been dark and cold for a long time.
Right. But even across this broadcast, if you went back and looked at the recording, you'd probably, I mean, I've noticed it because I'm used to looking at the moon in this phase. I've noticed even the X got more pronounced from the beginning of the broadcast until right now, just slightly. And this part of the crater here has gotten more illuminated. So if you go back to the beginning of the broadcast, you might see a slight difference, but
Okay.
not much, a teeny tiny bit.
Cool. Okay. Anything else that we want to point out the moon, or if there's any questions from the students about the moon, we'll be happy to answer any questions you might have.
Well, there's also one other thing you might want. So we couldn't see Clavius today, but I did notice you can see some craters within a crater
Hmm. Oh,
here.
yeah.
And from a geology standpoint, we talk about, what came first, the chicken or the egg, or, cross-cutting relationships. But the idea here is you try to figure out order of events. So you look at it here, you can see there's some lava in this crater, and there's 1, 2, 3, 4, and the 5 craters within this larger one right here. And you have to ask people what came first. So does anyone have any idea what out of all these things, all these craters here, which one came first? Any ideas? Okay.
Is it one of the bigger ones or one of the smaller ones?
It's the biggest one. The biggest one happened first. You can see that here. And then these little ones occurred afterwards. So the crater impact occurred. Notice there's no peak here. So, and these craters are, you can see them superimposed upon the other one. So this crater filled with lava would be the next step. And then this little tiny crater here, and this little tiny crater here. Next would be this one, and next would be this one. We're not sure about this one here because you can't tell if it would, it missed all these other craters here. More than likely, this happened at a different time than these over here. You can see that, but you can almost see it's sequential. One on top of the other, on top of the other. And occasionally, it doesn't happen all the time, but it does happen from time to time. I'll back out a little bit. Another thing Mary Lou was talking about with Proclus, you can see some of these rays here, these little lines going across the moon, and that's blast ejecta. So once the impact occurred, the crater was small, but the speed was relatively high. So it sent debris showering through the air and landing in different parts of the moon, kind of like, this way, this way, this way. So it just kind of rained across the moon particles and parts of the crater and parts of the impactor. So when you get closer to full moon, there'll be another crater, a famous one called Tycho. We don't quite see it yet. It's over down in this area over here, but some of its rays are actually illuminated right now, going over here. And when it's lit, you can see another one going across Tranquility also, but you can't quite see it all yet. But this is one of them, and this started in the southern hemisphere. So that's how large that that debris field can be, depending on the the angle it hits and how fast it's going. All right, so not really seeing many stars yet, but once I have some stars, I can do an alignment, and we can do some of the other features we're going to look at, the galaxies. But before before I end, notice here exposure time is 1/1000th of a second. So this keeps snapping pictures 1,000 times per second, and that's why it looks as dark as it does. So these pictures are coming in extremely fast. The opposite will happen later when we look at dim objects, because the moon is very bright. Dim objects, we have to increase this exposure time over many seconds to capture all the light coming in. And that's why a camera can see more detail than the human eye. And you'll see that in a few minutes once it gets dark enough. I guess I'll give it to Kevin now, and he'll give us a tour of the night sky tonight.
Yeah. While we're waiting,
there was a good question just now.
okay.
What would happen if there were new moon?
Do you want me to take? Or do you want? I'll answer part of that, and I guess Mary Lou can answer the rest of it. From a evolutionary standpoint, the moon is it's the Earth-Moon system is kind of unique in a way that a planet the size of our Earth has a satellite as large as it does, and as close as it is. So we have a lot of tidal forces. So, you know, if you ever look at the beach, you have low tide, high tide twice a day. But that played a big part in our evolution. In these amphibian type creatures would get washed in by the lunar tides, and they would get stranded in these tidal pools until the moon, which the tide would come back in and carry them back out. That being said, that encouraged amphibious type creatures, they were called tetrapods, if you ever want to look them up, to eventually adapt and become land-dwelling creatures later on. Without the moon, we might not be here right now having this discussion. We might be some type of aquatic creature swimming in the ocean somewhere, doing whatever it is we'd be doing. But Mary Lou, do you want to take the second part of that, or whatever you wanted to add?
Well, that's an interesting one, that we're stuck in a tidal pool somewhere. Another thing that the moon does is it stabilizes the Earth's rotation. So the Earth spins in 24 hours, but our spin axis is not pointed straight up in our orbit, but tilted over 23.5 degrees. And that allows the Earth to sort of wobble. And the fact that the moon is there, it kind of acts to help stabilize that, so it doesn't wobble so much. If the moon weren't there and the wobble went on for millions of years, then that would make the seasons different on the Earth and more extreme. So that might have also made it more difficult for evolution. You didn't have a place that had a really steady temperature and brightness for a long time, but things would be different, more different, more variable. Something else I like to think of when I look at the moon is, you know, when you look at it in the sky, it looks pretty small, and it really is fairly small. And we used to have a planet called Pluto, and now it's a dwarf planet. Pluto is smaller than our moon, so that's one of the reasons it's a dwarf now.
And one thing I'd like to add, and Mary Lou, you can tell me if this is how accurate this is, but in all the years that I've done, you know, not farming, but agriculture on a small scale, like gardening is the word I'm looking for. In the literature that I've read, the moon acts, you know, it creates these tidal forces because it pulls on the Earth essentially, which is probably the simplest way to explain it. It kind of pulls on it and causes the tides to kind of go in and out, and that's a whole nother discussion. But it also affects, from what I understand, plants. So when the moon aligns in a certain way with the sun and the Earth, it has a stronger effect, and it actually pulls the roots, has an effect to pull the roots of the plants down faster, or in a way to help them establish themselves. So there are some places that believe that certain crops should be planted on a certain moon because it will have an effect on the roots, and that plant will establish itself better. Have you ever heard anything about that? Can you validate?
Yeah, but I don't think it really works very much that way.
Okay.
Plants can grow without that anyway. And we've tried a lot of minor gardening up in spacecraft. So seeds have been planted on International Space Station, and all sorts of different experiments like that. And they have quite a different version of the length of the day and the length of and how the moon affects them. Doesn't seem to affect them any differently.
Okay.
So don't know.
Good to know. Thank you for sharing that with me.
Yeah. There's a,
Yeah.
never mind, go ahead.
Okay. Yeah, let's take a look at the sky here. I'm gonna bring
stop
up.
sharing and
Yeah, we
shut
can
my
stop.
Christmas lights off.
Oh yeah, there you go. So yeah, well,
Yeah.
Mark is going to be lining up his telescope for us so that we can move on to some other objects here. So what I'm going to do is I'm going to share my screen. I've got some planetarium software set up here, and let me make sure that this is full screen for everyone. Okay. Hold on a sec. I've got something selected here. Okay, there we go. That looks better. Let's make sure that my time is set correctly here. Yeah, we're set for about 9 o'clock. It's just after 9 o'clock now. And so this is a little piece of software. We mentioned last time we did a stargazing session for your school. This is Stellarium. This is a free program which you can go onto the Stellarium website and download this. It's a free program. It's also available as an app for various other devices like smartphones and tablets. So just go to stellarium.org and you can download that. And this is a nice little program that you can use to show you the sky. And so this is what we're pointed at right now, where the Mark's telescope is facing the southwest sky, and he's pointed right there at the moon. So let's look around at the nighttime sky, and I'll show you what is visible here in the evening sky. I guess a good place to start is the northern sky. And, you know, a lot of people are familiar with the star pattern known as the Big Dipper. And so let's look over to the northern sky here. Oops, let me zoom in just a little bit here and see if you can see the Big Dipper. You see the Big Dipper anywhere here in the northern part of the sky. Remember that the Big Dipper has 7 stars in it. And remember, the shape of the Big Dipper is kind of like a big spoon or maybe a pot with a long handle on it. And if you haven't spotted it yet, this time of year, it's really high in the northern sky. In fact, when you go outside at this time of night, just after 9 o'clock in the spring here, it's basically direct, as high as it can get in the northern sky. It's straight up in the north. And we're looking at it here. If you follow along with my pointer here, my mouse, you can see right in this area, you've got the 7 bright stars of the Big Dipper sitting right there. And you'll see 3 stars make up the handle and 4 stars make up the bowl of that big spoon that is the Big Dipper. And you'll notice right away that it looks kind of upside down, doesn't it? But that's the way it looks this time of year. It is upside down as you're facing north. So that's perfectly normal. And some people are surprised when we say that the Big Dipper is not really a constellation. It's not an official constellation. It's just a bright pattern that people noticed in the sky, and they gave it this nickname of the Big Dipper. It's actually part of a larger constellation, which you've probably heard of as well. This is Ursa Major, the constellation of Ursa Major. And this is a good time to look for Ursa Major because he's visible here in the evening sky. He's some parts of the year, in the wintertime especially, he's tough to spot because he's below the horizon at some point. Now, that's odd. I'm trying to highlight the constellation here for you, and I am not getting any results here. Boy, that's strange. I've got a constellation over in the wrong part of the sky that's highlighted here. Hold on a sec, let me select the star. Oh, there it goes. Okay, I had to select the star. So there's Ursa Major upside down in the sky. And you can see his he's upside down, so his nose is over here. So this is
It's a her. It's a mother bear.
Oh, that's true. Yeah, it is technically, if you want to think about the mythology that this is based on, Ursa Major represents Callisto in Greek and Roman stories, and so you really should say she, because she's kind of a big mama bear up there in the sky, and so she's upside down with her head right here. The body of the bear is here. The front legs are sticking out here in front of her, and the back legs like this, and the tail coming out like that. And so there's Ursa Major, the great bear. I think I've got a little bit of artwork here that shows you what she might look like. Use your imagination. And so there is Ursa Major, Callisto, upside down there in the sky. And when I show people the Big Dipper, sort of the Ursa Major like this, the first thing that they really recognize right away is that, boy, that bear has an awfully long tail, doesn't it? And yeah, it's way too long. If you know a bear, if you've ever seen a bear, you know that bears don't have big, long, bushy tails like a dog or a raccoon. It's got a short, little stubby tail. So you might wonder, why does this bear look so weird? Well, the Greeks and the Romans had told the story. I won't tell you the whole long story, but long story short, Zeus grabs this bear by its stubby little tail, picks him up. Zeus picks her up over his head and swings her around and around and flings her up into the sky. And her tail gets stretched all out of shape. And so that was the story that the Greeks and Romans told about how this bear got such a long tail. And as I mentioned, she's kind of a mama bear here in the sky. So where is her baby bear? Well, we can find the baby bear really close by, and we can do that by looking at the two stars at the front of the Big Dipper right there. And if we take those two stars, draw a straight line through those two stars, follow them down like this, you'll run into this star here, and you'll see there's another little group, and that little group of stars, 7 stars, just like the Big Dipper, and it has a similar shape. It is shaped like a little dipper, and so that's where this comes from. The name comes from. It looks like a little spoon there in the sky, but this is really the constellation of Ursa Minor, the baby bear. So there's the big bear and the little bear there in the northern sky. And something important to look for here is at the very tip of the little bear's tail, that star is Polaris. So that's the famous Polaris, the star Polaris, otherwise known, you probably heard of it, called the North Star. And so there's the famous North Star there in the sky at the tip of the little bear's tail. You can see it's due north. If we look, face north and look straight up in the sky, that's where the North Star is. And that's where you'll always find it. It's right there in the north. The North Pole of the Earth is pointing very close to the star. And so it's always there in the northern sky, at least from here in New Jersey. This is where we always see it. And so there's the bears and the star, the North Star, the star known as the North Star Polaris. So very, very useful for navigation, for figuring your way around. Before people had GPSs, they used the North Star to help them figure out where they were going. Let's see. We can move on to some other stars here, bright springtime stars, and we can find those bright stars by looking at the Big Dipper again. So look high up in the northern sky and look at the handle of the Big Dipper. If you take the handle of the Big Dipper, take that handle and imagine that you're pulling on it and stretch it out of shape there. And as you stretch it out, you run into this big, bright, sort of reddish star over here in the eastern part of the sky. And sometimes people will mistake this star for a planet because it has a little bit of a color to it, but it's not a planet, it's a star. It's a springtime star, and its name is Arcturus. This is the bright star Arcturus. And so this is a very bright star. One of the brighter stars that we can see here in New Jersey, and it comes up in the spring. It gets high up in the sky and is visible all through the summer. And so we get to see it for quite a long time. And even into the early fall, you can sometimes spot it at sunset, just before it goes down, too, before it sets. So it's a good star to know. It's a nice bright star, and it has a reddish orange color to it. It is a red giant star. And so if you ever wondered what would the sun look like in the future, just look over to Arcturus there. That's what our sun will look like at some point, say 1 billion or 2 billion years from now. It'll become a red giant star like this. So it has this kind of cool reddish surface to it. And so there is a nice star called Arcturus. By the way, Arcturus is in a constellation which you may not have heard of. It has an odd name. It looks like booties, is how it's spelled, but I believe the correct pronunciation is Baotes. Well, what is that? Well, he's the herdsman. In Greek and Roman stories, he was known as the herdsman. And so here you see a figure of a man, his shoulders. There are 2 stars here you can imagine as his shoulders. The star is his head, there's his body, and you can imagine some legs for him. I have trouble imagining these stars as a person up there in the sky. And so when I'm looking for Baotes, what I look for is a kite. It has kind of a kite shape to it, like a big kite here with Arcturus down at the bottom of the kite, and there's a little tail coming off, the short little tail coming off the kite there. So I can imagine as a kite. Other people like to imagine this as an ice cream cone. So there's the ice cream cone, and there's a scoop of ice cream on top. So that's a nice summertime treat. That's when you see this constellation in spring and summer. And so it's a good way of imagining these stars. Now we have another bright springtime star here, and it's kind of all by itself over in the southeast part of the sky. Arcturus is high up in the east now and southeast, but Spica is a bit lower. And so this is the star Spica, sort of a whitish colored star rising up there, kind of all by itself. But it's part of a famous constellation. This is the constellation known as Virgo. And even though it's a fairly famous constellation, it's kind of tough to see. It's got a lot of faint stars. And so it's kind of hard to imagine these stars as a woman, because that's what Virgo represents. Virgo represents Persephone in Greek and Roman stories. And if you read the story of Persephone, she represents springtime. She brings spring to the earth. And so that's appropriate. She's rising up here in the sky in the spring. And so it's an appropriate name for her. And so there's Virgo, the maiden, the person who brings the spring. And so there she is. She has a little ear of wheat or corn in her hand, and that's what the bright star Spica represents, is this ear of wheat there. And so plants are growing in the spring, and so that's associated with Virgo or Persephone. And so that's two nice springtime constellations and 2 nice bright springtime stars over there in the east and southeastern sky. And one thing we can do is give you a little trick here to remember where those stars are. Astronomers, we have a funny little sentence we like to use. We look at the handle of the Big Dipper and we say to ourselves, arc to Arcturus. Remember, arc is this kind of curved shape. That's an arc. And so you arc to Arcturus. And then you want to get down to Spica real fast. So you spike down to Spica, or speed down to Spica. So you arc to Arcturus and speed down to Spica. And that helps remember the names of those 2 stars and where they are in the sky. And so 2 nice bright stars and 2 nice bright constellations here to look for. I think that at some point later, we'll probably look at a couple of objects in a constellation that is nearby to Virgo. And so what you can do is you can arc to Arcturus You can spike down to Spica, and then you can leap over to the constellation Leo. So here's Leo, the constellation Leo, the famous lion, Leo the lion, and you can see the moon is right in front of the constellation Leo right now. You've got another bright springtime star here high up in the southern sky. This is the star Regulus. So there you have Regulus. They're known as the heart of the lion. And so what you can look for here in these stars when you leap over to Leo, look for these stars here. They are shaped like a backwards question mark in the sky. And you've got this bright star Regulus at the bottom. And the constellation Leo kind of looks like this. So there's the Leo's head and his body. There's his hindquarters and his tail over here. So you can just look for that big sort of backwards question mark shape, and that helps you find that constellation. So, okay, so that's a quick tour of a couple of different star patterns that we can see here in the springtime sky. Mark, how are you doing on your alignment of your telescope?
I'm good. It's interesting that you ended on Regulus because the telescope is pointed to Regulus right now.
Oh,
And,
you want to show us what it looks like in the telescope?
sure, why not?
Yeah. And that's a good thing to mention, what does a star look like when you look at it in a telescope? Well, let's find out. Might be a little bit surprised.
I think I got to get you to stop.
Oh, yeah, let me stop sharing. I'm sorry. Go ahead. I'm hogging the screen here.
So this is Regulus.
There we are. So
Yeah.
sometimes people are surprised when they see a star in a telescope because it really doesn't look very different from when you look at it with your eye. It just looks like a pinpoint. Maybe in a telescope, it might stand a little bit out from the background. It might might seem like it's glowing a little bit there, but it doesn't look all that different because even though we're magnifying it, these stars are really far away. I off the top of my head, I don't recall how far Regulus is, but it's many light years away from us. And so it's very tiny, it's actually quite a big star, but it looks tiny because it's so far away from us. And when you magnify it with a telescope, it's still, it doesn't give you too much detail in terms visually, at least.
The Regulus is actually a multiple star system.
Yes, yeah. So there's actually multiple stars there. Just the telescopes, even sometimes with very large telescopes, don't have enough resolution to show them to you. We have to use other methods to find them. We've got to look at the spectrum coming from that star. We got to look at the light that's coming from that star and study it using various instruments, and then we can figure out what it's made of and how many stars might be orbiting around it in that system. So, or even planets. You can figure out by studying the light whether or not there are planets orbiting around those stars sometimes.
So I think Regulus is actually 4 stars.
Yeah.
A pair and another pair rotating around each other, and it's about 80 light years away.
80. Oh, right. Okay. Yeah. 80
So
light years. Remember that a light year is the time that it takes, the distance that light travels in 1 year. So in miles, if you want to know how many miles that is, well, take 80 and multiply it by 6 trillion. And so get out your calculator and you can say, oh, well, what's 80 times 6? Well, that's 480 trillion miles away from us. And that's a star that is, less than 100 light years away from us. So it's, not that actually far. It may seem like a long distance, but it's not that far compared to other things that, especially some of the other things we're going to be looking at tonight when we look at a galaxy. Some of them are millions of light years away from us. And so even further out than that, much further out. Okay. So if you're aligned there, Mark, what do you want to show us first here? You want to look a little bit further out into space here. And
Try 65, M65 and M66 since we're
yeah,
close to them.
we're close by, you know.
Okay.
We've got a couple of galaxies here in the constellation Leo that are nice to look at. So Mark's
Kind of
going-
where his hind legs are.
Right, yeah, towards that little triangle at the back of the constellation that makes up his hindquarters. It's near there. And so Mark is going to move his telescope off of Regulus and point it over at a couple of galaxies. There goes the telescope. You can see a little streak that the star leaves behind as his telescope moves.
It'll take me a few moments to get the image up
Yes.
properly because I gotta adjust it. Well, they are right there. Pretty centered too.
Yeah.
Okay. So the moon, it looked better the other day when I was looking at it, but the moon is nearby. So that's also
Yeah, the moon,
interfering.
yeah, that's the one thing that the full moon can be a problem when you're trying to do some stargazing. That's the worst time to go stargazing because the moon is so bright that it kind of overwhelms some of the fainter objects that you might want to look at. So fortunately tonight we're headed towards first quarter, so we're still a week away from full moon. So fortunately the sky should be okay, but maybe not as nice as if there was no moon tonight, but it'll be better than a full moon day.
So start to get better. I am now
yes.
stacking them.
Okay, so now what Mark is doing is taking some images of these galaxies, and those images are stacking up, and that will improve our view here. So Mark, if you could point to the two galaxies.
To them right here.
There's one on the right, and there's one on the left.
They're both very close to each other in real space.
Mhm.
So the distance to each of them from the Earth is 35 million light years. So that's a long way away, but they're both 35 million light years from us. So they must be similar to each other. And then you see the sort of four little dots, which are stars between them, a quadrilateral there of some sort. And those stars are really close to us. They're within the Milky Way. So they're less than, let us say, 1,000 light years. And then so you go to the four stars and they're right there. And then you go way off in the distance to the 35 million light years away, which are those two galaxies. They're both spiral galaxies. And as the exposures get stacked up, we ought to be able to see maybe some spiral structure in them.
Might take a little more than it did on Friday.
Okay, so which one is 65?
65 is on the left and 66
And so
is
one of the
spiral.
differences that I know between the two of them is the number of new stars that they have each year. So galaxies are making new stars out of gas and dust and compacting it. And once you compact it enough, then it lights up. So the one on the left there has very little star formation. It's mostly stopped making new stars. But the one on the right, number 66, is doing lots of star formation. That one there.
You can start to see that it's a kind of a barred spiral. You see the bar here.
Oh yeah.
An arm here.
And that one, the one that is making new stars, is also making some very short-lived new stars. And so they live only 1 million years rather than billions of years, and then they blow themselves up, and they're called supernovas. And so that galaxy is really one of the best ones to look for a supernova in. And in the last 50 years, it's had 5 supernovas that we could see from Earth. So that's pretty amazing.
That's quite a bit of
That's
activity.
a lot of supernovas.
Yeah.
Bam, bam. And a lot of the other galaxies only have 1 per century.
Right.
This one's really, really moving along.
A lot of large, fast-lived, brightly burning stars in there.
Right, right. So our sun is kind of medium or medium small mass star. The stars that form that are more massive have a greater gravity, of course, and that means a greater temperature in their middle. And the middle then burns through their hydrogen fuel quicker, way quicker than the sun does. So they use up their whole supply of hydrogen in only maybe 1 million years. And our sun will be 10 billion years of trundling along, eating up its hydrogen supply. But then there are stars that are even longer lived than that. It looks like you're beginning to get some real structure on that thing. That's nice.
It's starting to get some nice looking structure finally.
And right in the middle of that bright dot in the middle of the fuzzy part right there, there's a black hole. Almost all galaxies have a black hole in their middle. And our Milky Way does as well.
Yep.
So that's something we learned only in, what, the last 50 years.
Yeah.
So do we want to look at the whirlpool? Something that in
Oh,
the
yes, please, let's
Yeah.
look. Well, that would be great.
Yeah, we want to take a look at the Whirlpool galaxy, which is a really nice one. And so Mark is going to move his telescope, and we're going to be looking over towards the Ursa Major. And so we're going to look at another galaxy, and this one has a really nice spiral shape to it. So you'll see why we call this the Whirlpool. If there was some stars zipping through the view. Anyway, it's going to take a moment to center on this galaxy because it's all the way to the other side of the sky. So it's going to go almost 180 degrees to get to this galaxy. Just remember that Leo is kind of in the south right now, and of course there's some majors over in the north, so he's going to turn his telescope all the way around in the opposite direction. Leslie asks, what would happen if a black hole swallows the Earth? Dun, dun, dun.
Not a good thing at all.
Not a good thing at all. We have a kind of a nickname for that. If a planet or a star or something gets sucked into a black hole, we call that spaghettification. And why is that? Well, because the gravitational pull of the black hole is so strong that it would just kind of pull anything that gets close to it apart. It'll just kind of stretch it out and pull it apart. And so we call that spaghettification. And so it would be, a real bad thing if a black hole were close to the Earth. Fortunately, we do not have to really worry about that. I try to remember what the closest black hole to us, one of the closest ones I think is over 1,200 light years away from us. So it's over 1,000 light years away from us. I think there was one that was discovered that was a little closer than the previous record, but it's still, something like almost 1,000 light years away from us, I think, as the closest black hole. Unfortunately, that's not really an issue for us. We're perfectly safe. Not gonna get
I'm glad to hear that.
yeah. And so, yes, if that actually happens, we could call it the end of the world. Yeah, that would be.
Yeah.
If we got sucked into a black hole, and
That would be a bad
actually,
day.
that's a bad day. Yeah, and especially bad when you consider that black holes are pretty much a one-way trip. In science fiction, we talk about spacecraft traveling through black holes. Like it's a subway system where you could drive into a black hole and then pop out somewhere else in the universe far away. But as far as we know, that's not really what happens when you go into a black hole. It just tears you apart, and whatever whatever your spacecraft was made of just gets sucked in and becomes
Oh.
part of the black hole. And
Good job, Mark.
oh yeah, this is a nice view. Yeah, this is a beautiful view. This is a nice galaxy to look at here in the springtime sky. It's near Earth's image and near the Big Dipper, and so it's relatively easy to find, and it's fairly bright, and so you get this really nice spiral shape to it.
Which
So
one is-
spiral arms are wound not so tightly as the Milky Way's.
Hmm.
So ours go around a bit more like twice as much as that.
Mhm.
So we're in a spiral arm in our galaxy called the Cygnus arm. And if you look out in the summer sky at the constellation Cygnus, then you're looking right down our spiral arm. And that's why there's lots of stars right there, because you're looking end on. It's like looking ahead at your highway, and you see lots of lights ahead of you. Oh, Mark, that's beautiful.
Yeah.
And this galaxy pair has had an interaction. So they're both spiral galaxies, and the little one on the lower left, which is called M51b, used to be closer to us than the big one, and it went past the big one, and now it's in the distance going away, and it's dragging part of the arm from the big one with it. So all those hundreds and hundreds of stars in that arm are being dragged after the interloper there, just receding off into the distance.
Can you point to that, Mark, so we can see that more clearly what Dr.
This
West is
is-
talking about?
This is the one that is coming. If you're thinking like your X, Y, and Z axis, so X would be horizontal, Y would be vertical, and Z would be going from us to away from us. This galaxy is heading this direction in the Z axis, away from us.
But what can you point to where there's that interaction where the one is sucking on, pulling the spiral arm from the
Yeah,
other
there
one?
you go.
Yeah.
Moving in here, so you can see the spiral arm of the whirlpool right here, and this one is the material is being pulled from this poor galaxy, which got too close, and is getting pulled into the larger galaxy. And so you can see this dark region here is a lot of gas and dust. It's being pulled out and pulled away, and that'll actually help form new stars in the star forming region.
So they both should be getting new stars soon, because they both got stuff from the other one.
True, yes.
Did you say this is the Whirlpool galaxy?
This
Yeah.
is the whirlpool.
Yes.
Yeah, this is
Awesome.
the whirlpool.
Otherwise known as M51.
And 51.
M51.
And also galaxies that look like this, where it's clearly face on to us, the big one on the right, and you can see the spiral arms really clearly. That's called a grand design spiral. I think it's a grand design, that one. Yeah, it is. It's pretty cool.
How far away are we talking, Mary Lou? This is like
Yeah.
This one's 31 million light years away. So sort of of the same order as those
Yeah.
two we saw in Leo, which were 35 million. This is 31 million.
but larger, I'd imagine.
Right.
Yeah.
Right.
Mark,
And
do
The
you
whole
think,
galaxy is about the size of the Milky Way. But there are some that are bigger than the Milky Way or it. But yeah, sorry, go ahead.
I was just going to ask Mark, do you think that we would be able to get M13 in the telescope tonight? Is it too early yet, or?
Well, that'd be cool if we could do that.
Just crossing the tree boundary right now.
So not quite yet.
A few minutes from now, yeah.
Okay, so we could try to get that as well.
I could try. I might be able to try M3 if you like.
Oh, well, yeah,
Sure.
let's try that. Yeah. Because I wanted to, we don't want to keep our students too long tonight.
Right.
We do want to, it would be nice to show them a star cluster. So
Right.
that's why I mentioned it.
I mean, yeah, I mean, since we're so close to 13, I can see if it clears, it might. It's close.
Okay. Okay.
It's less. Before
Well,
I get
either,
off this though,
yeah.
have a
Oh,
look,
sure.
you can see how much the image has rotated.
Mhm.
The sky has moved. But it's, the fact that it's stacking the image, it lines up on all these stars and moves one image on top of the other.
Yeah.
But in doing so, the sky has also moved. So this part of the sky is gone.
Yeah.
So let me, I'm going to stop the stack. And I'm going to clear the stack. And let me get back to like 5 seconds.
Now, if we're going to move the telescope off to, you're going to try for M13 instead of going to M3?
I'll try 13 first, yeah. And
Okay.
if it doesn't work, then
So-
we'll go right to M3.
So let me show them on Stellarium where you're going to point the telescope while you're.
Sure. And I'll do that now while you do this.
So let me share my screen again, and let me show you where we're going. We're going to go off to another constellation, which we haven't mentioned yet. It's rising up in the eastern sky. And kind of similar to Virgo, this is a constellation which is named after a fairly famous character from mythology, but his constellation is actually not really that bright. You got to look for it carefully. And one thing that you can do is you can look for a very bright star in the spring and summer sky called Vega. And right now, at this time in the middle of May, at say almost 10 p.m., it's just rising up. So we've got Vega sitting right here, rising up into the northeast part of the sky. And remember, we pointed out Arcturus, sort of reddish colored star Arcturus right over here. And so you want to look for those two bright stars. You got Vega and Arcturus. And we're going to kind of in between them, this is where you'll find a constellation named after Hercules. So this is the famous hero, a Greek and Roman hero, Hercules, or Heracles, as he's sometimes called. And so this is where Hercules is. And often when he is illustrated, when this constellation is illustrated, people think of him like this. His head is down over here, and he's upside down. And actually, this particular artist drew him battling the Hydra. That's one of his stories, famous stories of him battling this a monster that has all these heads. And so he's battling the Hydra there. I like to think of him the other way around, though. I find it a lot easier to imagine him right side up. So I imagine that these two stars here are his shoulders. These two stars are his hips here. And so you have this little box of stars. And that's what I look for. I look in between Arcturus and Vega. I look for that little box of stars here. And I imagine that his head is up here. His arms are sticking up. He's got one arm over his head, and his legs are coming down like this below him. And so I think of him as stick figure. And where Mark is going to be pointing his telescope is right under Hercules' armpit. So you look at his armpit right there, and you can point a telescope at this area, and you'll see a little fuzzy spot there in the sky. And this is where you'll find a star cluster. What is a star cluster? Well, stars do come in these bunches in the sky, and often stars are born in clusters. This is a very old cluster that's located pretty far out. It's actually you can kind of think of it as a satellite of the Milky Way galaxy. This is a bunch of stars that were formed many billions of years ago, fairly early on in the history of the universe. And this bunch of stars is orbiting here around the Milky Way. We can see it here in the constellation Hercules. It has a nickname. It's known as M13. This is M13 in the Messier catalog, and sometimes just simply referred to as the Hercules cluster. And so Mark is going to center his telescope on this area. And as I mentioned, we're going to be looking at the kind of armpit of Hercules here. And we're going to zoom in and take a look and see if we can see the M13 here. So any luck, Mark? And
Yeah, we're good. We're good to go.
stop sharing and Mark can show us what his telescope is seeing. And there we are. Okay, great.
Yeah, we
Wow.
Beautiful.
just cleared the screen.
Yeah,
The trees rather.
yeah.
But you can zoom in and see how so if we were if stars were a neighborhood, we'd be in like middle of New York City here, in really packed close together.
Yeah, this has something like almost 1 million stars in it. So this cluster is a big cluster of stars, and they were all kind of orbiting each other. They're all kind of bound by gravity, orbiting each other, and they've been there for billions of years. A very old cluster of stars, and it's pretty far out there. I'm trying to remember. It's about 30,000 light years away from us, Mary Lou.
Yeah, I have 22,000 light years from us. So
Oh,
it's
okay.
thousands rather than millions.
Right. Yeah. So this is much closer. This is, as I mentioned, kind of a satellite of the Milky Way. This is much closer than the other galaxies that are much further out. And so this is kind of a little satellite of our Milky Way. But yeah, it's about 20,000 light years away from us. And you're looking at almost 1 million stars there. So very exciting. And we call these clusters globular clusters. You can see why. They're kind of round. They kind of look like these globes of stars. And so very pretty to look at. Nice view there of M13.
So if we were on a planet orbiting one of these stars, we'd pretty much have no nighttime or darn near close.
Right. Yeah.
Be a problem. Yeah.
Do any of the students know how far away is the nearest star to our sun, to our solar system?
Good question. Let's see if anyone answers.
Yeah. How many light years away do you think the closest star is to the sun?
I know they're Googling feverishly.
Okay, that's fine.
Yep.
Let them find it out. And then while you're looking, what's the name of the nearest star?
Yeah.
Uh-huh. Famous in song and story.
While we're waiting for an answer, did I understand correctly that this globular star cluster is found in the constellation Hercules?
Mhm.
Okay.
Yep. Hercules.
Milky Way has quite a few of these globular clusters, maybe 100, 150 of them. So they're scattered around different constellations. But this one is in Hercules, and it's the best one.
Yeah, just about.
Remarkable.
Okay.
I think a little over 11 billion, if I'm correct.
For
The
age,
cluster.
for age, or
Yeah, like 11 billion.
yeah, that sounds about right. Yeah.
What, 11 billion years old?
Yeah, a lot older than you and me.
Yeah, I was going to say, it looks great for being that old.
Yeah, it looks pretty good for being that old, don't you think?
A couple
So
of
that means that a lot of these stars are red giants.
Yeah.
They have aged off the main sequence to be red giants. And but this one is surprising, and some of the other globular clusters are surprising also, in that right near the middle you find some young stars. They're called blue stragglers.
Well, yeah.
You can see them in here, right there, that
Oh,
one
yeah.
over there.
That one over there.
Yeah. You want to talk about those for a second, Mary Lou? Or
Well, so when a star ages, as it moves along in age, what it's doing is it's changing in its middle the hydrogen to helium. But that never gets even 50% of the way out through the star before it dies. But if you have two stars that are close together and run into each other, smash each other up, then they could reform as a star which has some fresh hydrogen in the middle. And that starts it off as a young star again. So that's the way we think these blue stragglers have formed, that in these great clusters, the stars are moving around and they're close enough together, they can have a collision one with the other. There's that one right there. That looks good.
There's a couple.
And so the new stars light up as blue. And there's a bunch of them in this cluster. Mostly in the middle where it's with more chance of a collision happening. So did anybody find out what the name or the distance of our nearest star to us is? I think we have to stop pretty soon, but maybe we should just tell you about that.
Yeah.
I don't
Yeah,
know what the nearest star is. Okay, thank you, Oliver. So the nearest star is called Alpha Centauri. And they're often science fiction stories. We should go to Alpha Centauri, whatever. But anyway, it's 4 light years away. And so it means the light that comes to us now from Alpha Centauri left there 4 years ago, when all of us were 4 years younger. At any rate, that's the normal sort of spacing in our part of the Milky Way, which we're sort of toward the outskirts. Stars are generally 4 light years from any other star. But if you go to one of these clusters, like this one here, the stars are not light years apart, but only light months apart, maybe even only 1 light month apart. So they're still nowhere touching, and their solar systems are nowhere touching each other. But the light from one to the other only takes like a month to get there rather than years to get there. And since everything is moving, that gives them a better chance of having a collision. So I thought that was kind of interesting. I think it's really nearly 10 o'clock here.
Yeah.
And
Yeah. So I think it's time to wrap things up, right? We got to look at a couple of things. We got a good look at a couple of galaxies, nice star clusters. That's a good place to stop, I think. And so we hope you enjoyed our little tour of the nighttime sky. And something that I'd like to mention, we do have a solar eclipse coming up that's visible here in New Jersey. It's going to be a little tough to view, though, because it's happening at sunrise. And we don't get to see the whole eclipse. We only get to see part of it. Is a partial eclipse here in New Jersey, but it's a pretty good one. And what our club is going to be doing is we're going to have a broadcast, kind of like this, where we're going to set up a telescope and take a look at that eclipse. Hopefully, if the weather's good, we'll be able to have this view, a live view of the eclipse happening. And so we'll get the link to that to you. We're going to have it on our YouTube channel. Our astronomy club has a YouTube channel, and you can get up early. Remember, the sun is rising pretty early, around 5:30 a.m. This will be starting, and it'll last about an hour. So between 5:30 and 6:30 a.m., the eclipsed sun will be rising up over the horizon. So it might be a really interesting thing to look at. And so we're going to try to view it, and hopefully you can join us on YouTube. And as I mentioned, we'll get that link to our YouTube channel too, so you can join us on. It's a Thursday morning, Thursday, June 10th. And so join us then for a sunrise eclipse.
Hope the weather cooperates.
Yeah, hopefully.
Knock on wood.
Mr. Taylor, you want to say anything else to the students before we go?
No, just real quickly, thanks for coming and staying up late, and hope to see you at 5:30 on June 10th. Of course, I'll see you on the in-between in school bopping around, but hope to see you on June 10th. That could be quite an epic experience and something to remember for quite some time.
Good night.
Yep.
Good
Thank
night,
you,
folks.
guys. Thank you so
Thanks
much.
for joining us.
Have a good rest of your night.
You too.